High in the Himalayas, far above the villages, beyond the forests, a silent lake rests peacefully between towering mountains. Its water is crystal clear, its surface is calm. Tourists would probably call it beautiful. Scientists look at it and ask a question: how long will that natural dam hold? Because sometimes the most dangerous floods begin in places where it has never rained. This is the story of Glacial Lake Outburst Flood, or GLOF. Imagine placing a bucket beneath a melting block of ice. Hour after hour, drop by drop, water fills the bucket. Eventually, the bucket becomes full. Now imagine that instead of a bucket, the water is trapped behind a fragile wall made not of concrete, but of loose rocks, sand, mud, and ice. That is exactly how many glacial lakes are formed. Let's travel thousands of years back. During the Ice Age, massive glaciers slowly moved down mountain valleys. As these glaciers advanced, they scraped rocks from the mountains and pushed them forward. Over time, huge piles of rocks, gravel, and soil accumulated at the glacier's edge. These piles are called moraines. Think of a bulldozer pushing heaps of debris ahead of it. When the climate began warming, the glaciers started melting. They slowly retreated uphill, but the moraine remained where it was. Behind this natural wall, meltwater accumulated. Gradually, a lake was formed. This is called a glacial lake. Now comes the danger. Unlike a dam built by engineers, a moraine dam is naturally formed. It is uneven, weak, unstable. It was never designed to hold millions of cubic meters of water. Imagine building a dam using piles of loose stones and wet sand. Would you completely trust it? Probably not. Yet, that is exactly what many Himalayan glacial lakes depend on. As global temperatures continue to rise, glaciers melt faster. More meltwater flows into these lakes. The lakes grow larger. The pressure against the moraine increases. The natural dam becomes weaker. Everything appears calm until one sudden event changes everything. Suppose a massive chunk of ice falls into the lake, or a landslide crashes into it, or an avalanche plunges into the water. The impact creates enormous waves, like dropping a giant rock into a small pond. Only this pond contains millions of tons of water. The water overtops the moraine dam. Water begins eroding the loose rocks. The small breach rapidly widens. Within minutes, the entire dam collapses. Millions of cubic meters of water explode downstream. This catastrophic event is called a glacial lake outburst flood. Think of a balloon filled with water. As long as the rubber holds, nothing happens. But the moment it bursts, all the water rushes out at once. A glacial lake outburst flood behaves in much the same way. Except instead of flooding your room, it can devastate entire valleys. The flood moves with tremendous force. It carries enormous boulders, trees, ice blocks, mud, debris, everything in its path. Bridges collapse, roads disappear, hydroelectric projects suffer severe damage, villages are buried, lives are lost. Because the flood often arrives with very little warning. One of the most tragic recent examples occurred in Sikkim in October 2023. A glacial lake known as South Lonak Lake breached after extreme weather and heavy inflows, triggering a devastating glacial lake outburst flood. The flood surged through the Teesta River Valley. The Teesta 3 hydroelectric project was destroyed. Bridges were washed away, entire settlements were devastated. The disaster reminded India that climate change is no longer a distant environmental concern. It is a present day disaster management challenge. Why are the Himalayas especially vulnerable? Because they are often called the third pole. After Antarctica and the Arctic, the Himalayas contain one of the world's largest reserves of ice. Thousands of glaciers exist across the Himalayan region. As temperatures rise, many glaciers retreat. Many glacial lakes expand. This increases the number of potentially dangerous lakes. Countries including India, Nepal, Bhutan, Pakistan, and China all face this shared Himalayan risk. Can glacial lake outburst floods be prevented? We cannot stop glaciers from melting overnight, but we can reduce the risks. Scientists continuously monitor vulnerable glacial lakes using satellite imagery, drone surveys, field inspections, remote sensing, early warning systems. Some dangerous lakes are partially drained through engineering measures to reduce water pressure. Communities downstream are trained in disaster preparedness. Excavation plans are prepared. Because while nature cannot always be controlled, its impacts can often be reduced. Now remember this important distinction. People often confuse a flash flood with a glacier lake outburst flood. A flash flood is usually triggered by intense rainfall over a short period. A glacial lake outburst flood originates when a glacial lake suddenly breaches, releasing stored meltwater, often without any rainfall occurring in the affected valley. The source of the flood is what makes the difference. So, the next time you hear a glacial lake outburst flood has occurred, don't imagine an ordinary river overflowing. Imagine a giant natural reservoir silently filling over years behind a fragile wall of rocks and ice. Everything appears peaceful until one small trigger, a landslide, an avalanche, a collapsing ice block, and in a matter of minutes, years of stored water are released with unimaginable force. That is why scientists closely monitor glacial lakes, because the real danger is not the lake itself. It is the fragile natural dam holding it back. And in an era of climate change, understanding glacial lake outburst floods is not just about geography. It is about protecting lives, infrastructure, and fragile mountain ecosystems.